In the quiet halls of early 20th century Europe, where chalk dust floated like mist over blackboards, a new kind of storm was brewing, one not of thunder, but of thought. For centuries, the world of science had been built upon pillars of certainty. The laws of Newton reigned supreme, describing the motion of planets, the fall of apples, and even the turning of clock gears. Everything had a cause, and every cause led to a predictable effect. To understand the universe meant to measure it, to calculate it, to know it completely. It was a universe of order, and man stood proudly as its rational interpreter. But then something happened, a faint tremor deep within the invisible world of the atom. Experiments began revealing cracks in the grand machinery of classical physics. Light, once believed to be only a wave, started behaving like a stream of particles. Electrons refused to move in neat circular orbits. Instead, they seemed to flicker in and out of existence, like whispers of reality itself. Suddenly, the rules that had explained everything from the motion of cannonballs to the swing of pendulums no longer worked when applied to the realm of the very small. This was the birth of quantum uncertainty, a phrase that would unsettle not only science but philosophy, logic, and even human understanding of truth. It wasn't a single discovery, but a gradual awakening. One by one, physicists began to realize that the microscopic world followed rules utterly alien to human intuition. At the heart of this awakening stood a man who would later be known as the dreamer of quantum mechanics, Erwin Schrödinger. Born in 1887 in Vienna, Schrödinger was a child of the classical world. He grew up surrounded by the elegance of mathematics and the certainty of Newtonian physics. To him, the universe was a beautifully composed symphony, precise, harmonious, predictable. But even as a student, he was not content with formulas alone. He sought meaning, essence, and unity between the seen and unseen. His mind, as curious as it was disciplined, carried both the heart of a philosopher and the precision of a scientist. By the early 1920s, a group of young physicists, Heisenberg, Bohr, and others, were already revolutionizing physics. They had proposed that at the atomic level, particles like electrons did not have definite positions or velocities until measured. Instead, they existed in a strange blur of possibilities, governed by probabilities rather than certainties. This was Heisenberg's uncertainty principle, a shocking idea that declared, the more precisely you know one aspect of a particle, its position for instance, the less precisely you can know another. Its speed, reality, at its most fundamental level, was uncertain. To the scientific mind of that era, raised on centuries of determinism, this was madness. Could the universe, which had once obeyed clockwork precision, now behave like a dream, fluid, unpredictable, and dependent on observation? Many refused to accept it. Schrödinger himself was both fascinated and disturbed. He admired the boldness of the new quantum mechanics but could not believe that nature, so elegant and continuous, could be ruled by randomness. He wanted to restore beauty to chaos, to find an equation that would unite order with uncertainty. And so, between 1925 and 1926, Schrödinger began to dream a new dream. While Heisenberg used abstract mathematical matrices to describe quantum systems, Schrödinger approached the mystery differently. He imagined particles not as points, but as waves of probability, ripples of existence spread out across space. To him, every electron, every atom, every bit of matter was a wave that carried within it all its possible states. Out of this vision emerged what would become one of the most famous equations in all of physics, the Schrödinger equation. It was a bridge between two worlds. On one side stood classical determinism, the belief that if you knew all forces and conditions, you could predict every event in the universe. On the other stood quantum indeterminacy, the realization that the future could never be fully known. Schrödinger's equation did not eliminate uncertainty, but it gave it form, language, and meaning. It showed how particles evolve as waves of possibility, and how observation collapses those waves into a single outcome, the reality we see. Yet behind his calm mathematical expressions there was turmoil. Schrödinger was not content with abstract success. He felt that physics was losing touch with reality. that it was turning into a game of numbers detached from the living essence of the world. He sought clarity. What does it mean that something can be in many states at once? What does observation truly do? Does the act of looking create reality? To grasp the weight of his challenge, one must remember what came before: the classical worldview, established by Isaac Newton and refined by Laplace, painted a universe like a perfect clock. If one could measure every particle and every force, one could predict the future with absolute precision. In this vision, randomness was only a symptom of ignorance. If you didn't know why a coin landed heads or tails, it wasn't because of chance, it was because you didn't measure the air currents, spin, or velocity precisely enough. There was no mystery in nature, only human limitation. But quantum physics tore that comfort apart. Here was a world where measurement itself changed what was being measured, where particles existed as smears of probability until a human or a detector observed them. The universe, once seen as a machine, now looked like a poem written in invisible ink, revealed only when read. Schrödinger's challenge was not just scientific, it was existential. He was daring to confront the soul of science itself. He wanted to know, can we truly call something real if its state depends on whether we observe it? Are we participants in reality or merely its witnesses? This rebellion against classical thought was not loud or defiant. It was quiet, poetic, and deeply philosophical. Schrödinger's writings, even his technical papers, carried a sense of awe. He spoke of the universe not as a collection of objects, but as a single continuous field of energy and consciousness. He often drew inspiration from Eastern philosophies, particularly Vedanta, which taught that all existence is one. Perhaps, he mused, the uncertainty we see in the quantum world is not chaos, but the reflection of an underlying unity that our limited senses cannot grasp. Still, the scientific world demanded proof, not poetry, and proof came in abundance. The predictions made by quantum mechanics were astonishingly accurate. Electrons behaved exactly as the equations described. Atoms emitted light in precise frequencies predicted by Schrödinger's models. Quantum mechanics worked. It explained everything classical physics could not. Yet, the deeper question remained unanswered. What did it mean? In universities and research institutes, debates raged between two camps: the realists and the idealists. The realists, like Einstein, believed that quantum mechanics was incomplete, that hidden variables must exist to restore determinism. Einstein famously said, "God does not play dice with the universe," but Schrödinger's work implied that maybe, just maybe, the dice were the universe itself. That uncertainty wasn't a flaw but a fundamental truth. Schrödinger's dream became a new kind of revolution. He was not overthrowing science, he was expanding it. He was asking scientists to accept that reality could be dual, layered, and dependent on the act of observation. The electron could be a particle and a wave. Existence could be both determined and uncertain. It was a call to humility, a reminder that human knowledge might always touch only the shadow of truth. Through his wave mechanics, Schrödinger showed that what we call reality might be a tapestry woven from probabilities. Each thread represents a possible outcome, and observation chooses which thread becomes visible, but the others never vanish. They remain in the unseen pattern of potential. In this sense, his work hinted at ideas that would much later inspire multiverse theories and interpretations of parallel realities. Imagine it, a single electron, existing everywhere at once, only collapsing into a specific point when measured, the universe itself, constantly choosing one possibility from countless others, unfolding like a cosmic dream. This was the new vision of existence that Schrödinger helped bring to light, a universe not built of solid things but of interactions, relationships, and observation. Yet this vision came at a cost. For scientists trained in the elegance of certainty, this new reality felt uncomfortable, even absurd. How could something exist in multiple states at once? How could the mere act of looking decide its fate? Schrödinger himself wrestled with these contradictions. He believed in the equations he derived, but found their implications haunting. He once wrote that if quantum mechanics is right, then the world we perceive is not made of things but of possibilities, realities waiting to be born. In many ways, his challenge to classical thought was a challenge to human arrogance. For centuries we believed we could stand outside the universe and measure it as an observer, separate from what we observe. But Schrödinger showed that the observer is part of the system, that consciousness itself might be entangled with the fabric of reality. The dreamer and the dream were inseparable. To grasp how profound this was, picture the universe as a vast ocean. Classical physics saw it as a sea of particles, each with a defined position and trajectory, tiny billiard balls moving through space. Schrödinger's vision, however, revealed waves, fluid, overlapping, interconnected. When two waves meet, they don't collide, they interfere, amplify, or cancel each other. Similarly, in the quantum world, possibilities overlap, influencing one another until an observation collapses them into one outcome. Reality, then, is not a fixed map, but a living ocean of potential. This oceanic view of existence brought Schrödinger both fame and discomfort. He had given science a new tool, but he had also opened a door to unsettling questions. He could describe how quantum uncertainty worked, but not why it existed. What is it about observation that transforms possibility into reality? Does the universe exist independent of consciousness, or does consciousness complete it? These questions would echo for decades through laboratories, classrooms, and even art and literature. Even as he developed his theories, Schrödinger could feel the resistance of tradition. The guardians of classical thought were not ready to abandon determinism. They argued that uncertainty was only temporary, that someday, with better instruments, scientists would uncover the hidden variables behind it all. But Schrödinger sensed otherwise. He saw that uncertainty was not a symptom, it was the essence. The atom, in its restless dance, was showing humanity the limits of its understanding. And so, in quiet defiance, Schrödinger continued to refine his equations, driven by both mathematical beauty and philosophical wonder. He wasn't content with being a scientist who solved problems. He wanted to be the thinker who understood what those solutions meant. His notebooks reveal a man caught between logic and mystery, between certainty and surrender. By the mid-1920s, the world began to realize that there was no turning back. Quantum mechanics had arrived, and Schrödinger's wave equation was at its heart. It became the foundation of chemistry, atomic theory, and modern technology. But beneath all those triumphs lay a deeper legacy, the realization that the universe could no longer be described as purely objective. To measure it is to change it, to know it is to shape it. That was Schrödinger's true challenge to classical thought, the insistence that science must not only calculate, but also contemplate. That every equation hides a whisper of philosophy, that every experiment touches the mystery of being. In that sense, the birth of quantum uncertainty was also the birth of humility, a humbling reminder that even the brightest minds could only glimpse the surface of an infinite truth. It was as if nature had placed a veil over her secrets, inviting humanity not to conquer her, but to wonder. As the world crossed the threshold into the late 1920s, the winds of science carried a new scent, one of awe, confusion, and quiet rebellion. Physicists across Europe were no longer certain whether they were uncovering nature's truths or merely brushing against shadows of their own perception. At the center of this intellectual storm stood Erwin Schrödinger, the calm dreamer with the fierce conviction that reality could not be reduced to randomness. His equations had given order to uncertainty, yet the deeper implications of his discovery were beginning to haunt him. In lecture halls from Copenhagen to Berlin, chalkboards filled with strange symbols, psi, h, 2, the mathematical language of the new quantum world. Schrödinger's wave equation had spread like wildfire, uniting scattered puzzles under one elegant expression. Every electron's behavior, every atom's whisper, could be described by a single mathematical rhythm. To the physicist's ear, it was music. Yet to the philosopher in Schrödinger, it was something far more profound, a song about the hidden architecture of existence. Still, one could sense his unease. The very equation that brought him fame also revealed an unsettling truth, that the waves he described were not real in the tangible sense. They did not represent physical ripples in space, like sound or water waves. They were waves of probability, symbols of what might be rather than what is. This idea, though mathematically consistent, cut deeply into the foundation of science itself, For centuries, the role of physics had been to describe what is. Now it was forced to describe what could be, acknowledging that the universe at its core might never offer certainty. Schrödinger's peers, particularly Niels Bohr and Werner Heisenberg, embraced this strange new landscape with bold enthusiasm. To them, uncertainty wasn't a flaw, it was the signature of nature's freedom. Heisenberg's uncertainty principle declared that measurement itself alters the reality being measured, and Bohr's Copenhagen interpretation insisted that particles exist only as probabilities until observed. Together, they painted a picture of a participatory universe, one in which observation collapses possibility into reality, but Schrödinger found this deeply unsatisfying. He had not set out to make the universe depend on the mind of the observer. He wanted to reveal a deeper, continuous order beneath the surface of chaos. He believed that quantum theory, though accurate, was incomplete, that it described appearances, not essence. It was as if humanity had discovered the grammar of reality without understanding the meaning of its words. So he pushed further. He began to write essays blending science with philosophy, urging his readers to look beyond measurement and mathematics. He reminded them that physics, at its best, is a dialogue with nature, not merely a manipulation of data. His writings were laced with poetic intensity. What we observe as material bodies and forces, he wrote, are nothing but shapes and variations in the structure of space. To Schrödinger, matter was not a collection of discrete particles. It was a seamless field of energy, vibrating with infinite possibilities. He often compared it to music, a single symphony played on many instruments, each note resonating through the cosmos. Yet most scientists, consumed by the practical success of quantum mechanics, were content to ignore such metaphors. They had found equations that worked, and that was enough. But Schrödinger refused to settle for pragmatism. He was haunted by a question that no experiment could answer. If the universe exists only as a field of probabilities until observed, then what was it before life existed to observe it? Did the stars not shine before eyes evolved to see them? Did atoms not move before minds arose to measure them? The Copenhagen interpretation offered no comfort. It left reality dangling between existence and non-existence, dependent on awareness. It was to challenge this paradox that Schrödinger conceived his most famous and infamous thought experiment, the cat in the box. He imagined a sealed chamber containing a cat, a tiny bit of radioactive material, and a vial of poison. If an atom decayed, the poison would be released, killing the cat. Quantum theory said that until the box was opened, the atom existed in a superposition of decayed and undecayed states. Therefore, the cat must also be both alive and dead at the same time. It was absurd, and that was exactly his point. Schrödinger wasn't trying to prove that cats could inhabit ghostly in-between worlds. He was mocking the literal interpretation of quantum mechanics. He wanted his colleagues to see the contradiction, to confront how the same laws that described atoms could not coherently describe life-sized reality. His cat was a protest, a challenge to the growing acceptance of a universe ruled by uncertainty. Yet, ironically, the world embraced the paradox instead of rejecting it. Schrödinger's cat became the symbol of quantum mystery, the playful, haunting emblem of a universe that defied logic. The experiment that was meant to expose the limits of quantum theory ended up immortalizing them. The cat refused to die, or to live, and in doing so, it became one of the most famous creatures in scientific history. As decades passed, physicists began to appreciate just how far-reaching Schrödinger's challenge truly was. His wave mechanics formed the foundation of nearly every technological revolution that followed. From semiconductors and transistors to lasers and quantum computers, all modern technology rests on the mathematics that once filled his quiet Viennese notebooks. Yet beneath that triumph lies the philosophical question that continues to haunt science. Does mathematics describe reality or merely predict what we will observe? The elegance of Schrödinger's equation cannot conceal the abyss it opened. It tells us how quantum systems evolve, but not why observation makes them choose a specific outcome. It predicts probabilities perfectly, but remains silent about the mechanism of choice. In this silence, philosophers, mystics, and scientists alike have found room for speculation. Some see consciousness as the missing key, the observer's mind as the force that collapses the wave function. Others believe that all possible outcomes occur simultaneously in parallel universes, branching endlessly with every quantum event. Schrödinger himself might have smiled at the poetry of both ideas, even as he struggled to reconcile them with reason. To understand his intellectual loneliness, one must picture him during the 1930s, walking through the alpine paths of Austria, pondering equations while the world outside spiraled toward war. His notebooks were filled not only with calculations but with reflections on life, death, and unity. He read the Upanishads, the ancient Hindu texts that spoke of a single consciousness underlying all existence. There, he found a resonance with his own thoughts. The total number of minds in the universe is one, he would later write. In truth, there is only one mind. To him, quantum uncertainty was not a void of meaning. It was the shadow cast by a deeper oneness. Just as ocean waves rise and fall without ever being separate from the sea, so too, he believed, are all forms of existence expressions of a single underlying reality. The apparent randomness of the quantum world was not chaos. It was the pulse of an interconnected whole, too vast and subtle for human perception to grasp. Yet the scientific establishment, increasingly pragmatic, turned away from metaphysics. The success of quantum mechanics in explaining experimental data made philosophical reflection seem unnecessary. Engineers were using Schrödinger's equations to build the early tools of the modern world. Few had time to ponder the spiritual meaning behind them. The golden age of discovery became the age of application. Still, a quiet current of Schrödinger's influence persisted, flowing beneath the surface of physics and philosophy alike. His challenge to classical thought was not confined to laboratories. It seeped into psychology, literature, and art. Writers began to explore fragmented realities, dual existences, and uncertain truths. Painters tried to capture the tension between seen and unseen worlds. Philosophers debated whether consciousness was a participant in creation or merely its witness. Everywhere, echoes of quantum uncertainty began to reshape how humanity viewed itself. In classrooms today, students learn the Schrödinger equation as a mathematical tool, rarely pausing to feel its philosophical weight. But if one listens closely, behind every line of algebra lies a question that cannot be answered by numbers alone. What is existence before it is measured? That question, whispered by Schrödinger's cat, reverberates through every atom and every mind. When we step back and view his work in the larger sweep of history, we see that Schrödinger's challenge was not merely scientific, it was human. He was asking us to let go of the illusion of control, to accept that the world is not a static object but a living mystery. He showed that the act of knowing transforms what is known, and in doing so, he redefined what it means to observe, to exist, to be. The birth of quantum uncertainty marked a turning point in human consciousness. It was the moment when science for the first time confronted its own limitations. The universe was no longer a stage upon which matter moved in predictable patterns. It was a participatory drama, a dialogue between reality and perception. The observer was no longer separate from the observed. The line between subject and object began to blur, and out of that blur emerged a new understanding of being. In this new worldview, uncertainty is not the enemy of knowledge, it is its foundation. Without uncertainty, there can be no discovery, no creativity, no evolution. Schrödinger's legacy reminds us that the unknown is not something to be feared, but something to be embraced. For it is in uncertainty that possibility lives, even today, as scientists explore quantum computing, teleportation, and entanglement. They walk in Schrödinger's shadow. Every bit of data, every wave function, every paradox bears his signature. A reminder that knowledge is always incomplete, and that mystery is not the opposite of truth but its companion. If you close your eyes and listen, you can almost hear the echo of his thought, part whisper, part warning. Do not mistake measurement for understanding. The equations may describe the dance, but they do not explain the dancer. The universe is more than the sum of its probabilities. It is the living fabric that gives rise to them. The birth of quantum uncertainty, then, was not merely the dawn of a new physics, it was the awakening of a new philosophy of existence. It forced humanity to reconsider the nature of reality, the role of the observer, and the unity between mind and matter. It challenged the arrogance of certainty and invited the humility of wonder, and it was Schrödinger, the quiet dreamer of Vienna, who gave that awakening its voice. He once wrote that the scientist's task is not to find ultimate truth, but to see the world fresh each day, as if it had just been created. Perhaps that is the essence of his legacy, to look at an atom, a wave, or even a cat in a box, and realize that beneath every paradox lies a deeper harmony, a truth that can be felt, even if it cannot yet be proved. In the end, Schrödinger's challenge to classical thought was a challenge to all of us. To accept that existence is not fixed but fluid, that the universe is not a clock but a dream, and that within every uncertainty lies the spark of creation itself. The quantum dreamer had shown the world that reality is not something to be conquered, but something to be contemplated. And though he has long since passed, the question he raised still hovers in the silent space between what is known and what is possible. Are we the observers of the universe, or are we the universe observing itself? It begins not with a cat, but with a question so small it hides inside the invisible heart of an atom, and yet so large it reaches beyond the stars. In the early 1930s, the world of physics was celebrating triumph and trembling at its own discovery. The new quantum mechanics, strange, powerful, and unsettling, had rewritten the language of reality. It could predict with astonishing precision how atoms emitted light, how electrons behaved, how everything from chemistry to electricity operated, but underneath that precision was a whisper that would not go away. That reality itself might depend on being observed, that the universe, at its core, was not a thing but a possibility. And it was here, in this twilight between knowledge and mystery, that Erwin Schrödinger decided to dream a paradox that would outlive him. He had seen what quantum mechanics had become, a triumph of mathematics, a revolution of logic, and a nightmare of meaning. The Copenhagen interpretation, championed by Niels Bohr and Werner Heisenberg, had turned the physical world into a dance of probabilities. According to their view, a particle existed not as a solid object, but as a wave of potential outcomes. Only when it was measured, when someone looked, did it collapse into one reality. Before observation, it was neither here nor there, but somehow both. It was elegant in theory and horrifying in implication. If observation created reality, then what of the world that existed before observers, before life, before eyes, before thought? Was the moon not there when no one looked? Schrödinger could not accept that. To him, nature was not a puppet pulled by the strings of observation. The world had to exist independently of the human gaze. He respected Bohr and Heisenberg, admired their brilliance, but he also felt a deep unease. Something was missing, something vital. Common sense, perhaps, or the continuity of reality. He believed the quantum formalism worked mathematically but was being misunderstood philosophically, and so he sought to expose its absurdity, not by rejecting it, but by following its logic to its most impossible conclusion. The year was 1935. Europe trembled under growing political tension, and yet within Schrödinger's mind an even stranger tension grew, between what was known and what was believed. He sat down to write a paper not about experiments or formulas, but about the nature of truth. In that paper he introduced what would become the most famous thought experiment in the history of science, the cat that was both alive and dead. He imagined a sealed steel box containing a cat, a tiny radioactive substance, a Geiger counter, a hammer, and a vial of poison. The setup was simple but diabolically clever. If even a single atom in the radioactive material decayed within an hour, the Geiger counter would trigger the hammer, breaking the vial and releasing the poison. The cat would die. If the atom did not decay, the cat would live. According to the laws of quantum mechanics, until the box was opened and the atom observed, that atom existed in a superposition, a state of being both decayed and not decayed at the same time. Therefore, Schrödinger argued, if the quantum rules applied to macroscopic things, the cat too must be both alive and dead, its fate suspended in a ghostly limbo until an observer lifted the lid. He had built a nightmare of logic, a mirror that reflected, not reality itself, but the absurd consequences of how physicists were beginning to interpret it. Schrödinger's cat was not an endorsement of quantum weirdness. It was a protest. It was his way of saying, if you take this interpretation seriously, you end up with a dead and alive cat. Surely this cannot be the whole story. Surely the world is not built on paradox. But the beauty of paradox is that it cannot be confined to the intentions of its creator. Once born, it lives a life of its own. The world heard of Schrödinger's cat, and instead of rejecting it as absurd, it fell in love with it. Students laughed nervously at it, philosophers wept over it, physicists argued for decades about what it meant. The cat had escaped its box, not physically, but intellectually, and prowled into the collective imagination of humanity. In laboratories, physicists began to perform real experiments that echoed the cat's dilemma. They trapped photons, electrons, and even small molecules in states of superposition. They watched as particles interfered with themselves, as if existing in two places at once. The quantum world seemed to confirm that Schrödinger's absurdity was, in some mysterious way, true. The cat, symbolic though it was, had revealed something profound, that reality does not behave the way we think it should. To understand why this struck such a deep chord, one must understand what was at stake. For millennia, humanity had believed in an objective universe, a world that existed independently of our perception. Whether we looked or not, the sun rose, the wind blew, and the stars burned. But quantum mechanics had begun to suggest otherwise. If observation determined outcomes, then perhaps the act of looking was not passive but creative. Perhaps consciousness and reality were entangled. Schrödinger himself resisted this mystical drift. He did not want science to slip into solipsism, where only the observer's mind mattered. He wanted to restore the reality of the cat, to insist that it must be either alive or dead, whether or not we know which. But the paradox refused to die, precisely because it revealed something deeper than even Schrödinger intended. The cat was not just a commentary on physics, it was a reflection of existence itself. Every human being lives like Schrödinger's cat. Before decisions are made, before paths are chosen, our lives too exist in superpositions of what could be, what might be, what almost was. Every unopened door holds infinite outcomes. Observation in this broader sense is not just scientific, it is existential. To observe is to collapse the infinite into the particular. To choose is to destroy possibilities. To live is to make the universe decide. And so, in the decades that followed, Schrödinger's paradox evolved beyond the laboratory. Philosophers saw in it a symbol of the tension between potential and reality, between knowledge and ignorance. Artists began to paint the cat as a metaphor for the duality of human consciousness, the way we can hold contradictory emotions, beliefs, and dreams within us, alive and dead all at once. Psychologists spoke of cognitive superpositions, where minds hold competing truths until one is accepted. Even theologians found echoes of the divine mystery in the cat's dual state, the coexistence of life and death, being and non-being. But to the scientist, the paradox remained a challenge. Could reality truly depend on measurement? Was there a way to describe the world without invoking an observer? For years, interpretations multiplied like reflections in a hall of mirrors. Some physicists, like Hugh Everett, proposed that all possibilities actually happen, that every time an observation occurs, the universe splits into countless parallel worlds. In one universe, the cat lives. In another, it dies. Both are real. This became known as the many worlds interpretation, a direct descendant of Schrödinger's thought experiment. Others, like Bohm, proposed hidden variables, unseen factors that restore determinism beneath the apparent chaos. Each idea tried to rescue the cat from its paradox, yet none could cage the mystery completely. Meanwhile, Schrödinger himself watched with both pride and melancholy as his imaginary cat became a legend. He had intended it as satire, but it had transformed into the emblem of quantum philosophy. It appeared in textbooks, popular magazines, and cartoons. Its image traveled from classrooms to coffee mugs, from serious debate to playful metaphor. Few scientific ideas had ever escaped academia so completely. But behind the humor lingered a haunting truth. The cat was not just a joke. It was the most direct question science had ever asked about the nature of existence. For what, after all, is reality? Is it the sum of what we can measure, or something that exists regardless of our awareness? The cat forces us to confront the uncomfortable idea that the line between existence and non-existence is not as sharp as we think. It invites us to consider that reality might be participatory, that it might need interaction to manifest. The thought experiment also raised profound questions about consciousness. If observation collapses the wave function, what qualifies as an observer? Is it the human mind or any form of measurement, even mechanical? Does consciousness play a role in shaping reality, or is it simply another quantum system entangled with others? The cat, though silent, seemed to ask these questions endlessly, meowing in the ears of physicists and philosophers alike. In its strange way, the paradox turned physics into a mirror. When scientists peered into the cat's box, they were no longer just studying particles, they were studying themselves. The observer became part of the experiment, and science, once a detached study of nature, became an active participation. This shift was not just intellectual but spiritual. The cat forced humanity to admit that our understanding of existence was incomplete, that reality is not something we stand outside of but something we help create. It is here that Schrödinger's cat becomes more than a metaphor. It becomes a symbol of modern consciousness. In an age of uncertainty, where truth itself seems fluid and fragmented, the cat's duality mirrors our collective state. We live in overlapping worlds, the digital and the physical, the real and the virtual, the seen and the unseen. Like the cat, we occupy multiple identities, each both alive and dormant, until the world forces a choice. And yet, there is a quiet wisdom hidden in the paradox. Schrödinger's cat reminds us that truth is not singular but layered. Reality is not binary. It is a continuum of potential. To be alive is to exist in a superposition of dreams, fears, and choices. The collapse never happens until we open the box, until we dare to look. By imagining a cat that defied life and death, Schrödinger had unintentionally given humanity a new way to think about reality itself. His paradox became a bridge between science and philosophy, between the measurable and the mystical. It whispered that uncertainty is not a flaw but a fundamental feature of being, that mystery is not an obstacle but a doorway. Even today the cat sleeps and wakes in the minds of those who seek to understand existence. Its box is no longer steel but metaphorical, the closed chamber of human perception, where possibilities remain entangled until awareness opens the lid. When we look into that box, what we find is not merely a cat, but a reflection of ourselves, creatures suspended between knowing and not knowing, dreaming and observing, alive and dead in the same breath of time. The making of the paradox, then, was not the creation of confusion, it was the revelation of complexity. Schrödinger had not trapped a cat, he had trapped the human condition itself. Time moves on, but the box remains closed. Decades pass, theories evolve, and technology reshapes the boundaries of knowledge, yet the image of that sealed chamber persists like an echo in the collective imagination. Inside it sleeps the eternal question: what is real before we look? For the physicists of the mid-20th century, that question became both a torment and a muse. The paradox of Schrödinger's cat was no longer a mere curiosity, it had become a philosophical fault line dividing the very foundations of science. In laboratories around the world, scientists sought to push the boundaries of the thought experiment into physical form. They built delicate devices capable of isolating atoms, photons, and molecules in near-perfect vacuum, attempting to hold them between states of existence. It was as though humanity was trying to peek into the box without opening it, to observe without disturbing, to witness the raw face of uncertainty. What they found was astonishing when left unmeasured. Quantum systems behaved exactly as the theory predicted, interfering with themselves, existing in multiple states at once. But the moment an observation occurred, the possibilities collapsed. It was as though nature refused to be both seen and mysterious. The act of looking was not passive. It was participatory. The paradox deepened. Schrödinger's imaginary cat was no longer an impossibility, but a symbol of the strange truth that observation changes the observed. And this truth began to stretch beyond the laboratory. Philosophers began to argue that all human experience was a kind of observation, a constant collapsing of potential realities into a single lived moment. Every choice, every perception, was a tiny act of measurement. The cat's dual state became the metaphor for life itself, the unseen realm of possibilities that vanish the instant we decide, the infinite futures we destroy by choosing one. Yet, even as quantum theory gained success, Schrödinger himself remained restless. He watched as his paradox took on lives of its own, some brilliant, some absurd. Journalists turned it into a cultural emblem. Artists painted it as an emblem of modern doubt. Mystics adopted it as proof that consciousness shapes the cosmos. Schrödinger would sometimes smile at these interpretations, and at other times sigh. The cat had escaped its philosophical cage and wandered into mythology. But perhaps that was inevitable, for what he had created was not just a scientific example, it was an archetype. To understand why this archetype endures, one must see the cat not as an animal, but as an idea. Inside that sealed box lies the conflict between two ways of knowing, the empirical and the experiential. The empirical seeks evidence, measurement, verification. The experiential recognizes that reality includes the unseen, the potential, the imagined, the emotional. Schrödinger's paradox forced these two ways of knowing to confront each other. It said, in essence, if you insist on reducing reality to what you can measure, you may have to accept that unmeasured reality is both everything and nothing at once. As the decades unfolded, the paradox matured. It inspired new generations of thinkers to explore interpretations that might reconcile the contradiction. Some turned toward the notion of decoherence, the idea that interaction with the environment itself counts as observation, forcing systems into definite states long before human eyes ever see them. Others embraced the many worlds idea, imagining that every quantum event splits reality into parallel universes where all outcomes occur. These interpretations did not kill the cat, they multiplied it, spreading its dual fate across infinite worlds. In one universe, the cat stretches lazily in the light. In another, it lies motionless. The experiment becomes eternal, replayed endlessly across the fabric of reality. But beyond the mathematics, there is a deeper poetry. The paradox reminds us that knowledge is born not from answers but from tension. Without the discomfort of uncertainty, discovery would stagnate. The cat's dual state is a symbol of that tension, the living contradiction that drives curiosity. It tells us that progress in understanding comes not from erasing paradox, but from dwelling within it long enough to see what it reveals. To visualize this, imagine a quiet room. On the table sits a closed box. Around it stand generations of thinkers, scientists with instruments, philosophers with notebooks, poets with open hearts. Each looks at the box and sees something different. The scientist sees an experiment, a test of theory. The philosopher sees a metaphor for consciousness. The poet sees the fragile boundary between life and death. And in a sense, they are all correct, because the box is not an object. It is a mirror. What one sees within it depends on what one brings to it. The cat becomes whatever we believe reality to be. In this way, Schrödinger's paradox became the mirror of our age. The 20th century was an age of contradictions, of progress and destruction, reason and madness, technology and alienation, nuclear weapons and space travel, electronic brains and existential dread, all emerged from the same scientific revolution that birthed the quantum, the cat's duality, alive yet dead, real yet unreal, reflected the duality of human civilization itself. The paradox that haunted physics came to haunt humanity. Schrödinger himself, later in life, grew philosophical, even mystical. He believed that beneath the appearance of multiplicity, there was unity, that consciousness was one and indivisible. His cat, though born from frustration, had led him to a vision of wholeness. He saw that paradox was not failure, but harmony misunderstood. The wave and the particle, the alive and the dead, were not opposites, but aspects of a deeper totality. Reality, he began to suspect, was not composed of separate things at all, but of relationships, patterns, interconnections. Like a vast symphony, in which each note exists only through its resonance with others. This insight resonates far beyond physics. In the cat's superposition, we find echoes of human experience. The way memory and possibility coexist, the way dreams shape perception, the way imagination alters truth. Each moment of awareness is its own observation, collapsing the infinite into the immediate. We are in a way both the cat and the observer, part of the experiment, yet also the consciousness that opens the box. Modern quantum experiments continue to push this boundary further. Scientists now create systems of entangled particles, twins that remain mysteriously connected across vast distances. When one is measured, the other responds instantly, as if distance itself were irrelevant. Einstein had once called this spooky action at a distance, but experiments confirm it beyond doubt. It is as though reality itself is woven from threads of connection that defy separation. Schrödinger's cat, suspended between states, becomes a metaphor for this cosmic entanglement. It shows us that isolation is an illusion, that every act of observation ripples through the fabric of existence. In the modern world, the cat has evolved from metaphor to technology. Quantum computing, a field built upon superposition and entanglement, now seeks to harness the very paradox Schrödinger imagined. Instead of fearing uncertainty, scientists are using it as a tool. Quantum bits, or qubits, exist in multiple states simultaneously, allowing computers to process vast possibilities at once. The paradox that once mocked common sense has become the engine of future innovation. In a strange twist of fate, the cat that was meant to expose absurdity has become the patron saint of progress. And yet, despite all this progress, the philosophical echo remains. When we speak of data, algorithms, and artificial intelligence, we are still asking the same ancient question. What is real before it is observed? Our digital world, filled with virtual realities and simulated experiences, is a kind of modern superposition. Images, both real and unreal. Identities both alive and artificial. The cat, still half awake in its box, seems to whisper that perhaps the quantum mystery has merely expanded into new dimensions of human life. If we step back from the science and listen to the emotional undercurrent of Schrödinger's thought, we find a man searching for balance between reason and wonder. His cat was never about cruelty or confusion. It was about the fragility of understanding. It was a reminder that knowledge, however advanced, rests on assumptions we rarely question. The box represents those assumptions, the frameworks within which we think, measure, and define truth. When we open it, we are not merely observing reality, we are confronting the limits of our own perception. There is something almost spiritual in that image. The cat, silent and unseen, embodies the mystery that every human soul feels, the tension between life and death, presence and absence, certainty and faith. It reminds us that existence is not a static state, but a dynamic unfolding. We are always in transition, always in superposition, always on the edge between what we know and what we cannot yet imagine. Schrödinger's paradox thus endures because it transcends its origin. It is not bound to physics alone, it is a language of being. The scientist sees in it a principle, the philosopher sees a riddle, the poet sees a mirror, and the mystic sees a revelation. All are reflections of the same truth, that reality is not a fixed structure, but an evolving relationship between consciousness and the cosmos. When we close our eyes and imagine the box again, it becomes clear that the cat's fate is not the central question. The real mystery is the space between states, the living moment before observation, the shimmer of possibility before decision. That is the heart of the paradox, the place where science meets art, where logic meets love. It is the recognition that what we call reality is always in motion, always in becoming, always half hidden behind the veil of perception. Perhaps this is why the story continues to fascinate us. It is not about physics anymore, it is about us. We too are paradoxes, mixtures of certainty and doubt, matter and meaning, wave and particle. We live in superposition every time we stand between choices, every time we imagine a future that has not yet come to pass. Each breath is an observation collapsing one possibility among countless others. And when we look back, as Schrödinger once did, we realize that life itself is the ultimate quantum experiment. So, the cat remains. Its box may be imaginary, but its lesson is eternal. It teaches us that the universe is not an object to be mastered, but a mystery to be experienced. It tells us that truth is not singular but relational, that understanding grows from the willingness to dwell in uncertainty. It reminds us that even in paradox there is beauty, perhaps the deepest beauty of all. In the final years of his life, Schrödinger often spoke less of equations and more of unity. He believed that, behind all diversity lay a single consciousness, a single reality expressing itself in myriad forms. The cat, in its suspended state, became to him a symbol of that unity, the meeting point of opposites, the bridge between mind and matter. He never resolved the paradox, because he came to see that it was not meant to be resolved, it was meant to be lived. And so, every time we ask what the cat represents, every time we debate its meaning, we keep the paradox alive. We open the box not to find a definitive answer, but to find ourselves reflected in its question. The cat is alive and dead, real and unreal, because we are too, creatures caught between knowledge and mystery, between being and becoming. The making of this paradox, then, is the making of awareness itself. It shows us that the quest for certainty is not the end of science but its beginning, that wonder is not ignorance but wisdom in its purest form. Schrödinger's cat endures because it speaks the oldest truth in the newest language, that existence at its core is not a thing but a story, one still being written every time we dare to look. In the beginning, science sought only to observe. Observation was the sacred act through which truth was revealed, the lens through which nature's secrets were made visible. For centuries it had been a simple equation. To exist was to be measurable. The telescope brought the heavens closer, the microscope unveiled the invisible, and every new instrument promised to bridge the distance between the observer and the observed. But in the dawn of the 20th century, as the light of reason reached into the heart of the atom, something strange happened. The very act of observing began to interfere with what was being observed. Reality, once thought to be indifferent to our gaze, began to tremble under it. It was as if the universe, when watched too closely, grew self-conscious. This was the birth of a clash unlike any in science before, a confrontation between observation and existence, between what is and what is seen. In the realm of the quantum, where particles flicker like thoughts, the observer could no longer claim neutrality. To look was to touch, to measure was to change, and this realization shattered the foundation of objectivity upon which classical physics had been built. To understand the magnitude of this collision, one must step into the world that existed before it. Classical science had drawn a sharp boundary between the observer and the observed. A stone, a star, a drop of water. All existed independently of the eyes that perceived them. The scientist's role was that of a detached witness, standing apart from the universe and merely describing it. This worldview, perfected by Newton, Laplace, and Maxwell, painted a cosmos of absolute order. The planets moved in predictable ellipses, the tides obeyed the pull of gravity, and light traveled in measurable waves. Everything had a cause, every effect could be calculated, and existence was a grand mechanism running without interference from human thought. Then came the quantum revolution, a storm of equations and experiments that revealed cracks in that mechanical order. Light behaved as both wave and particle. Electrons refused to travel in predictable paths. Energy was not continuous but came in discrete packets, called quanta. The deeper scientists looked, the more uncertain the universe became. At first, this uncertainty seemed like an error, a limitation of technology or understanding. But the more they refined their measurements, the clearer it became. Uncertainty was not an accident, it was a law. Werner Heisenberg gave this chaos a name, the uncertainty principle. He showed mathematically that one could never know both the position and momentum of a particle with perfect accuracy. The more precisely one measured one property, the less precisely the other could be known. It was not a matter of faulty instruments, it was a fundamental feature of nature itself. At the smallest scales, existence was smeared across probabilities. The very concept of a particle being somewhere lost meaning until someone observed it. And there, in that fragile instant of observation, everything changed. A particle that had been spread out like a mist of possibilities suddenly became something definite. The wave of probabilities collapsed into a single outcome. The act of measurement forced the universe to make a choice. For scientists raised in the tradition of detachment, this was heresy. It suggested that reality did not exist in a complete form until it was observed. It implied that the observer was not outside the experiment, but within it, that consciousness itself might be part of the machinery of the cosmos. In 1927, at a conference in Solvay, some of the greatest minds in history gathered to wrestle with this revelation. Einstein, Bohr, Planck, Heisenberg, and Schrödinger sat in heated debate over what it all meant. Einstein could not accept that observation created reality. "Do you really believe," he asked, "that the moon exists only when you look at it?" Bohr replied calmly, "Can you prove that it does when you are not looking?" The room fell silent. What had once been physics was now philosophy. What had once been certainty was now paradox. This tension, the clash between observation and existence, was not just intellectual. It was emotional, almost spiritual. It forced humanity to confront the limits of its own understanding. If the universe behaved differently when observed, what did that say about the nature of reality itself? Was reality objective, existing independently of the mind, or was it participatory, shaped by awareness? The questions cut to the heart of existence. As the equations of quantum mechanics matured, they continued to confirm that the observer could not be removed from the equation. Experiments with electrons passing through slits in a barrier revealed a haunting truth. When unobserved, the electrons behaved like waves, spreading out and creating patterns of interference. But when detectors were placed to measure which slit the electron passed through, the wave pattern vanished, replaced by the pattern of discrete particles. The act of observation transformed behavior. The observer's choice determined the outcome. The universe, it seemed, was listening. This experiment, known as the double-slit experiment, became the ultimate symbol of the quantum mystery. It was repeated countless times, refined and extended with photons, atoms, even larger molecules. Each time, the same truth emerged. Observation changes reality. When the observer's gaze is removed, existence expands into possibility. When it is present, possibility collapses into fact. It was as if nature could not decide until someone asked the question. Philosophers saw in this a mirror of consciousness itself. What if awareness and reality are entangled? What if the mind does not simply register the world but participates in its unfolding? The idea was both thrilling and terrifying. It meant that human beings were not merely observers of the cosmos, they were participants in its creation. Every act of observation, every moment of awareness, was a tiny act of cosmic choice. Yet not everyone was ready to embrace this view. Einstein fought against it for the rest of his life. God does not play dice, he said, refusing to believe that randomness and observation ruled the universe. He searched for hidden variables, undiscovered laws that would restore order and determinism to nature. But the more experiments were performed, the more the evidence favored the strange truth of quantum mechanics. There were no hidden variables, no secret order waiting to be revealed. The dice, it seemed, were real, and they were rolling inside every atom. The clash between observation and existence thus became more than a scientific dispute. It became a question of worldview. It asked whether the universe is a fixed stage or a living story. If everything exists in a cloud of probability until observed, then the universe is in some sense unfinished, waiting for consciousness to bring it into focus. This idea resonated beyond physics, echoing through philosophy, psychology, and even art. Painters began to explore uncertainty in form and perspective. Writers spoke of fragmented realities and multiple truths. The human spirit, too, was learning to live with ambiguity. But the paradox deepened as experiments became more refined. In the 1960s, physicist John Bell formulated a theorem that tested the idea of hidden variables. His experiments showed that if quantum mechanics were correct, then particles could remain connected, entangled, even across vast distances. When one particle was observed, the other instantly reflected the change, no matter how far apart they were. It was as though the universe had no boundaries, as though observation in one place could influence existence in another. Einstein had called it spooky action at a distance, but Bell's experiments proved that this spookiness was real. Observation and existence were not separate. They were intertwined in a cosmic web. In the decades that followed, the implications grew even stranger. Scientists began to realize that measurement could not be separated from interaction. To observe something, one must exchange energy with it, shine light upon it, detect it, disturb it. Observation, in the quantum sense, was not passive but active. It was participation, interference, entanglement. The universe was not a painting on a wall, it was a performance, and to watch it was to join the act. This realization changed not only physics but the philosophy of science itself. The dream of total objectivity, the idea that the observer could stand apart from the world, was shattered. The observer and the observed were part of one continuous system. Knowledge itself became relational. What we know depends on how we look. Reality became a dialogue, not a monologue, and within that dialogue, human consciousness found a strange and central role. Quantum theory did not demand that awareness be mystical, but it hinted that awareness mattered. Without observation, the universe remained in a blur of probabilities. With it, form emerged, matter solidified, patterns appeared. It was as if consciousness were the light by which existence became visible to itself. Schrödinger, always the philosopher among physicists, sensed this long before it became fashionable. He believed that what we call reality is not separate from the act of perceiving. The world, he once wrote, is given to me only once, not one existing and one perceived. Subject and object are only one. He saw the clash between observation and existence, not as a conflict to be solved, but as a reflection of a deeper unity yet to be understood. This idea, that the act of seeing and the thing seen are inseparable, echoes ancient philosophies. In the Upanishads, the sages spoke of a universe that awakens to itself through awareness. In Taoist thought, the observer and the observed are the yin and yang of being, interdependent and mutually defining. In the West, poets and mystics alike intuited that perception shapes reality long before science proved it. Quantum mechanics gave this intuition mathematical form, yet the question remained unanswered. What exactly is the observer? Does consciousness truly collapse the wave function, or can mere interaction suffice? Physicists debated this endlessly. Some argued that the observer could be any measuring device, that the presence of a detector was enough. Others insisted that consciousness itself plays a fundamental role. The debate blurred the line between physics and metaphysics, between laboratory and philosophy. But perhaps the beauty of this clash lies in its refusal to resolve, for in the tension between observation and existence lies the spark of wonder that keeps science alive. It is a reminder that every act of seeing is an act of transformation, that we are not separate from the cosmos we seek to understand. The observer is not the master of reality, but its partner, its reflection, its voice. The clash between observation and existence is, in truth, a love story, a relationship between mind and matter, knowledge and mystery. It is the dance of awareness and being, forever intertwined, forever unfinished. Each experiment, each act of curiosity, is a step in that dance. And though the equations may one day evolve, the paradox at their heart will remain, whispering that the universe is not a static thing but a living question. The camera imagination opens once more on a silent laboratory, somewhere in the middle of the 20th century. Glass tubes hum with electricity. A beam of light cuts across a chamber, scattering dust like stars. A scientist stands motionless, eyes fixed on a flickering detector screen. Somewhere in that dim glow, a single photon makes its choice, to appear as a wave or as a particle. The outcome depends on whether it is being watched. It is a quiet moment, almost sacred, and yet it carries the weight of centuries of human thought. In that flicker lies the central drama of modern physics, the realization that the act of observation and the fact of existence are not two separate things, but parts of the same mystery. For generations, science had imagined itself as a mirror reflecting the universe. But now the mirror had discovered that it was part of the reflection. The observer was woven into the very fabric of what was observed. It was no longer possible to speak of nature as if it were an independent spectacle unfolding for human eyes. Nature was performing with us, through us, inside us. The conflict between observation and existence was not an argument between two forces, it was the revelation that they could never be divided at all. As this understanding deepened, the world began to change. The quantum age reshaped technology, art, and even the way people thought about knowledge itself. Transistors, lasers, computers, and medical imaging. All sprang from equations born in the fog of uncertainty. The same laws that told us reality was probabilistic also gave us the means to manipulate it. Humanity, in some strange irony, began to build certainty out of uncertainty. Yet beneath every technological marvel lingered a question that refused to fade. What is the world really when no one is looking? Experiments grew subtler. Scientists built detectors capable of recording the behavior of single particles, devices so sensitive they could capture events on the scale of billionths of a second. They placed them in elaborate setups, delayed choice experiments, quantum erasers, entanglement tests, and each time the results spoke the same haunting truth. The decision to observe seemed to reach backward in time, determining outcomes that had already happened. It was as though the universe waited until the last possible moment to decide what it had been all along. Time itself bent under the weight of observation. At conferences, physicists debated in language that blurred the border between mathematics and metaphysics. Some insisted that observation was merely a physical interaction, the coupling of systems, the exchange of energy. Others whispered that awareness itself might be fundamental, that consciousness and reality were two sides of one coin. There was no agreement, but perhaps agreement was never the goal. What mattered was that the old certainty had dissolved, replaced by a new humility before the unknown. The clash between observation and existence was no longer confined to laboratories. It had become a metaphor for the human condition. Every person, in every moment, stands at the intersection of what is and what could be. Before you act, infinite futures exist. Once you choose, only one remains. Observation is decision, and decision is creation. The physics of the atom mirrors the physics of the soul. Consider the life of an artist. A painter begins with a blank canvas, a field of pure potential. Every brushstroke collapses possibilities, defining one image while erasing countless others. The act of creation is an act of observation, the moment when imagination becomes reality. In that sense, every artist is a quantum participant, turning superposition into form. The same can be said of every thought, every word, every glance exchanged between human beings. Existence is not static, it is participatory. In quiet moments, Schrödinger himself must have felt the depth of this realization. The man who had written equations of waves now found himself carried by their philosophy. He once described the universe as a single mind, seeing itself from countless angles. To him, the clash between observation and existence was not a battle but a dialogue, an endless conversation between the conscious and the cosmic. The observer is the universe observing itself, he wrote, the awareness through which the world becomes aware. It was both science and poetry, an insight that touched the borders of mysticism. Others saw in this a danger, a temptation to blur the lines between measurable truth and subjective belief. Yet the paradox persisted precisely because it resisted confinement. The more we tried to explain it, the larger it grew. The double-slit experiment remained the emblem of this enigma, simple in design and infinite in meaning. Light passing through two slits behaves like a wave, creating an interference pattern. But when detectors are added to see which slit each photon goes through, the pattern changes, as if the photons know they are being watched. When the detectors are turned off again, the pattern returns. It is as if reality itself hides or reveals its form depending on whether consciousness is present. The implications reach beyond physics, into the philosophy of perception. What if reality is not a thing we discover, but a relationship we enter? What if the act of knowing is itself a form of being? In that light, observation is not invasion but communion, a meeting of mind and matter where both are changed. This way of seeing transforms science from a quest for domination into a practice of participation. The universe becomes less a machine and more a conversation, an ongoing exchange of information, attention, and meaning. And so the question evolves. Instead of asking whether observation creates existence, we begin to ask how the two weave together. In quantum language, this weaving is called entanglement, the mysterious connection that allows particles to remain linked across time and space. When one is measured, the other responds instantaneously, as if distance means nothing. The experiment is simple, but its implications are cosmic. It suggests that separation is an illusion, that every part of the universe contains echoes of every other part. To observe anything is, in some sense, to observe everything. The clash between observation and existence dissolves into interconnection. The poet might call this unity, the philosopher might call it being, the mystic might call it God. The physicist, cautious and precise, calls it non-locality. Different languages for the same truth. The universe is a web of relationships, and awareness is the thread that holds it together. The observer, by looking, does not merely see, they participate in the continual act of creation. In the 21st century, this realization began to influence new fields. Quantum information theory redefined observation as the transfer of information, the fundamental currency of reality. Quantum computing embraced superposition as power rather than problem. Quantum biology began to explore whether living systems use coherence and entanglement to sense and survive. In each domain, the old clash reappeared under new light. The observer and the observed were not opponents but partners in a grand experiment called existence. Still, a tension remains, because the human mind craves solidity. We want to believe in a world that is simply there, stable and definite. Yet every quantum measurement whispers otherwise. Beneath the surface of stability lies a restless ocean of probabilities, waiting for attention to shape them. The paradox is humbling. Reality is both independent and participatory, both solid and fluid, both existing and becoming. Observation does not create existence out of nothing. It reveals one face of an existence that is infinitely many-faced. Perhaps the real clash is not between observation and existence, but between two ways of knowing, one that demands control and another that accepts mystery. In the controlled world of classical science, to observe was to conquer, to measure was to master. In the quantum world, to observe is to join, to measure is to merge. The scientist becomes the poet, the experiment becomes the story, the universe becomes the audience and the performer at once. If we look deeper still, we see that this paradox extends to the level of consciousness itself. Neuroscience and philosophy now ask, what if observation, awareness, is not a byproduct of matter, but an intrinsic feature of it? What if consciousness is woven into the same quantum fabric that binds particles together? Some call this panpsychism, others call it speculation. But the question persists because the data refuses to silence it. When we observe, something happens that cannot be fully captured by equations. The leap from possibility to actuality feels like a gesture of will, a flicker of awareness translating potential into being. And maybe that is the secret. Schrödinger, Bohr, and Heisenberg were all circling in their own ways. The observer and the observed are two expressions of one reality, the dreamer and the dream. The conflict between them exists only when we try to divide them. When we see them as one, the paradox becomes harmony. Observation does not destroy existence, it completes it. Existence does not resist observation, it invites it. The universe becomes self-aware through every act of attention, every gaze of curiosity, every moment of wonder. This idea reshapes even the smallest human gesture. When you look at the night sky, those stars, though millions of years old, reach you only now, their light collapsing into your perception. In that moment, the universe and your awareness intertwine. You are observing, but you are also being observed by the same cosmic consciousness that pulses through galaxies and neurons alike. The clash dissolves in intimacy. Observation is not an intrusion into existence, it is its fulfillment. And so, the story circles back to its beginning. Science, which once sought to stand apart and observe, now finds itself drawn inward into the very mystery it studies. The instruments grow ever more precise, but the questions grow ever more human. What is reality? What is mind? What does it mean to exist? The answers remain uncertain, but perhaps uncertainty is the answer, for it is uncertainty that allows possibility, and possibility that gives rise to creation. In the end, the clash between observation and existence becomes a dance of opposites, tension that keeps the cosmos alive. Observation brings clarity, existence brings depth. Together they weave the fabric of experience, each incomplete without the other. The observer asks, and the universe responds. The universe presents, and the observer perceives. Between the question and the answer lies the infinite space of becoming, the living frontier where science and wonder meet. When Schrödinger imagined his cat, he did not know that his paradox would echo for a century, challenging not just physicists but philosophers, artists, and seekers of every kind. Yet the same question that haunted the cat's box echoes in every heart. Does the world exist without us, or are we part of its unfolding? Perhaps both are true. Perhaps existence is the stage, and observation the spotlight, and consciousness the play itself. The curtain never truly falls. For every observation is another beginning. The camera of the mind pans back now, beyond the lab, beyond the planet, beyond the stars. Everywhere there are observers, eyes, instruments, hearts, minds, each gazing outward, each bringing the universe into focus. The clash continues, not as conflict, but as creation. Observation and existence are no longer enemies, they are co-authors of reality, and as long as there are those who wonder, who look, who ask, the story of the universe will keep unfolding, one observation at a time. The story of Erwin Schrödinger cannot be told only through equations and experiments. It is also the story of a man who refused to let science and spirit drift apart, who believed that the search for truth must include not only the outer world of matter, but the inner world of meaning. In the early decades of the 20th century, physics had become dazzlingly successful yet strangely hollow. It could predict almost everything but explain almost nothing about why existence felt alive, conscious, aware. Schrödinger stood in that gap, watching his fellow scientists describe the universe as a vast mathematical machine, and he quietly asked whether numbers alone could ever describe the mystery of being. He had already changed physics forever with his wave equation, yet fame did not satisfy him. The more he understood the atom, the more he felt the silence inside it, the absence of purpose, the loneliness of mechanism. He began to read philosophy, late into the night, Plato, Schopenhauer, and the ancient Hindu texts known as the Upanishads. In their pages he found ideas that resonated with the quantum world he had uncovered. They spoke of a single reality appearing as many, of consciousness as the foundation from which all forms arise. It was as if the mathematics of quantum waves and the metaphors of Eastern thought were two languages describing the same ocean. Schrödinger's colleagues admired his brilliance but grew uneasy when he began to speak of unity, mind, and consciousness. Physics, they said, must remain free of metaphysics, but he could not separate them. To him, science without philosophy was blind precision. Philosophy without science was empty speculation. He dreamed of a synthesis, an understanding of the universe that would honor both the measurable and the mysterious. He saw consciousness not as an accident of matter, but as the ground of all reality. In his view, there was no strict boundary between observer and observed, self and world. The awareness that perceives and the phenomena perceived are aspects of one continuous whole. This conviction found voice in his later writings, especially his little book, What is Life? And there he tried to bridge biology and physics, asking how living organisms maintain order in a universe that tends toward disorder. The question led him beyond molecules to meaning. Life, he suggested, is a pattern sustained by the flow of information, a conversation between matter and mind. Though the book inspired generations of biologists, including the discoverers of DNA, its deeper message was philosophical, that life cannot be understood by dissecting it into parts. It must be seen as a unity that includes consciousness itself. In private letters, Schrödinger wrote that the world is a single mind experiencing itself from countless perspectives. The separations we perceive, between individuals, between species, between subject and object, are illusions born of limited awareness. When a person says I, they are using the same cosmic consciousness that says I in every creature. He believed that the deepest goal of science should not be domination over nature, but awakening to this shared identity. The universe, he said, is not made of things but of experiences, not of objects but of events within one vast field of awareness. Many scientists dismiss these ideas as poetic excess, yet Schrödinger never abandoned them. He saw poetry and precision as complementary, not contradictory. When he lectured, his voice carried both logic and wonder. He would trace a wave equation on the board and then pause, as if listening for something beyond mathematics, the faint heartbeat of meaning. To his students, he offered not only formulas but questions. What is knowledge? What is perception? What is the self that knows? He wanted them to see that the observer was not outside the experiment but woven into its very fabric. The more he meditated on these questions, the more he felt the unity of existence in a direct, almost mystical way. He would walk alone through the Alps and feel that the mountains, the air, and his own consciousness were one continuous presence. This was not religion in the traditional sense. It was an insight born from both physics and philosophy. The quantum world had shown him that isolation is illusion, that every particle vibrates in relation to others. Consciousness, he believed, was the same, an indivisible totality reflected in each living mind like sunlight in countless drops of dew. In the end, Schrödinger's struggle was not to prove his ideas, but to live them. He continued to write and teach, bridging science and philosophy, even when few listened. He died in 1961, leaving behind equations that power our technology and thoughts that still challenge our imagination. His legacy is more than mathematical. It is existential. He reminded humanity that knowledge and wisdom must walk together, that the world described by physics and the world felt by the heart are one and the same. His life stands as a quiet testimony to the possibility that the boundaries between science, philosophy, and consciousness are not walls but windows, through which the universe looks back at itself and knows that it exists. The experiment that exposed the limits of human understanding began not in a single moment, but as a series of awakenings, each one peeling back another layer of certainty. Science had always believed it could master reality through observation, yet in the heart of the quantum world, every measurement seemed to whisper that mastery was an illusion. The more deeply scientists looked, the more they realized that the act of looking changed what was being seen. This was not merely a discovery, it was a confrontation with the limits of what the human mind could comprehend. It was as if the universe itself had drawn a boundary, a soft and invisible line, reminding humanity that understanding has a price. The story of this experiment begins with a simple question: can we observe something without influencing it? In the classical world, the answer was yes. A telescope could reveal the planets without moving them. A microscope could magnify life without altering it. But in the quantum world, where particles are as delicate as dreams, the very act of observation disturbs what it touches. The first sign of this came from the double-slit experiment, a test so simple in design yet so profound in consequence that it remains one of the most haunting demonstrations in science. When particles like electrons or photons are fired through two slits, they create an interference pattern on a screen, behaving like waves. But when detectors are added to observe which slit they pass through, the pattern changes. They behave like particles instead. Observation collapses their wave-like potential into a single, concrete reality. It was as though nature refused to reveal both her faces at once. This experiment, repeated countless times and refined with unimaginable precision, became the mirror in which human reason saw its own reflection and blinked. It told scientists that the universe does not exist as a fixed, independent stage waiting to be measured. It exists in a state of possibility until interaction brings it into focus. That idea was more than disorienting. It was humbling. It meant that knowledge could never be complete, because to know something is to change it. The observer is forever entangled with the observed. The dreamer is part of the dream. In time, this realization spread beyond physics. Philosophers began to ask whether human perception itself might operate by similar rules. When we look at the world, do we see it as it is or as we make it? Are we participants in creation, shaping reality through our awareness, our choices, our expectations? The double-slit experiment had opened a door through which not only light, but meaning began to pour. Science, which had once promised certainty, now revealed mystery at the very core of existence, and the mystery deepened, in later variations of the experiment, delayed choice and quantum eraser tests. Scientists discovered that the decision to observe could influence results even after the event had occurred. The universe, it seemed, could rewrite its own past. Time, once thought to flow like a steady river, now appeared as a flexible fabric woven by observation itself. These results shook not just the equations of physics, but the foundations of reality as we understood it. Human understanding, so confident for so long, found itself face to face with a universe that refused to fit inside logic. Schrödinger's thought experiments, like his famous cat, symbolized the same unsettling truth. Between knowing and not knowing lies a zone of paradox that logic alone cannot penetrate. The cat is neither alive nor dead until observed, not because nature plays tricks, but because our concepts of life and death, of being and not being, may not apply in the way we think. The human mind, built to navigate a world of solid objects and linear time, struggles to grasp the fluid nature of the quantum realm. Here, opposites coexist, effects precede causes, and possibility reigns supreme. The experiment did not fail. It simply revealed that our definitions of success and failure were too small for the truth it uncovered. In that revelation lay both fear and beauty. Fear because it stripped away the illusion of control. Beauty because it invited wonder back into science. The limits of understanding are not walls but horizons. Beyond them lies not emptiness but potential. Every unanswered question becomes an opening, every paradox an invitation. Humanity, once proud of its intellect, learned humility in the presence of a cosmos that refused to be simplified. Einstein once said that the most incomprehensible thing about the universe is that it is comprehensible. But after the quantum experiments, even that comfort began to waver. The universe was comprehensible only up to a point, beyond which language faltered and mathematics turned into metaphor. Yet within that uncertainty, something essential was born, a recognition that mystery is not the opposite of knowledge, but its continuation. The experiment exposed our limits, yes, but it also illuminated the vastness of what remains to be discovered. When we stand before that mystery, we are no longer scientists alone, we are seekers. The double-slit experiment, the entangled particles, the living and dead cat, all remind us that reality is not a puzzle to be solved, but a relationship to be experienced. Every discovery reveals both understanding and unknowing, like twin faces of the same truth. Schrödinger's vision, once confined to the blackboards of physics, now touches philosophy, art, and the very idea of consciousness. The universe is no longer a silent machine, it is a conversation, one that listens as much as it speaks. Perhaps that is the true gift of the experiment that exposed the limits of understanding. It taught us that our curiosity is not a flaw but a bridge, connecting finite minds to infinite mystery. It showed us that even when comprehension fails, wonder remains. And in that wonder lies the deepest form of knowing, the quiet acknowledgement that the universe is both knowable and unknowable, real and potential, seen and unseen. The human mind may never grasp it fully, but perhaps it was never meant to. Perhaps the purpose of the experiment was not to reveal the universe's secrets, but to remind us that the act of seeking them is what makes us truly alive. The impact of Schrödinger's ideas on modern physics and technology reaches far beyond the quiet study rooms where his equations were first written. What began as a philosophical struggle to understand the invisible world of atoms has become the foundation of nearly every modern invention. The dream of the quantum world, the strange, uncertain, flickering domain that once seemed detached from daily life, now powers the devices that define it. Yet behind every laser beam, every transistor, every quantum computer lies the same paradox that once haunted Schrödinger's mind. The recognition that reality is built from probabilities, that matter and energy obey laws which defy human intuition, and that understanding does not remove mystery, it deepens it. When Schrödinger introduced his wave equation in 1926, it was a mathematical vision of how particles move not as solid objects, but as waves of probability. This equation became the backbone of quantum mechanics, a language that allows scientists to describe everything from the glow of a star to the flow of electricity through a microchip. In the early days, few could have imagined how these ideas would transform the physical world. The equations were abstract, filled with symbols and infinities, yet from their abstraction came the blueprint for the technologies that now hold our civilization together. The transistor, the tiny switch that is the heart of every computer and smartphone, was born from quantum understanding. Engineers learned that electrons do not move like marbles but tunnel through barriers, a process that defied classical physics. Without that insight, there would be no digital age. The laser, another child of quantum theory, emerged from the realization that atoms could release light in perfect synchrony, amplifying waves into a beam of pure energy. That beam now scans our groceries, powers medical surgeries, carries information through fiber optic cables, and reads the disks that store human memory. Even more astonishing are the technologies that seem to touch the edge of Schrödinger's imagination itself: quantum cryptography, quantum teleportation, and the birth of quantum computing. These fields harness the same principles that once seemed purely theoretical: superposition, where a system can exist in multiple states at once, and entanglement, where particles separated by vast distances remain mysteriously linked. In laboratories across the world, scientists are now building machines that calculate by exploiting this uncertainty, computers that think not in binary yes or no, but in a symphony of maybes. The paradox that once frightened philosophers has become the power source of the future. Yet even as technology grows more advanced, Schrödinger's philosophical legacy continues to whisper beneath it. Every quantum experiment reminds us that the act of observation still changes what is observed, that the boundary between reality and perception remains fluid. Engineers may harness the mathematics, but the meaning still echoes. The universe is not a rigid machine, but a living field of possibilities. The same wave functions that describe electrons also hint at something more profound, that everything in existence is interconnected, that the world of technology and the world of thought are made from the same invisible fabric. The reach of Schrödinger's influence extends beyond the laboratory into the very way humanity perceives reality. His work inspired not only physicists but artists, poets, and philosophers, who saw in his equations a new metaphor for existence itself. The notion that a particle can be both wave and point, both here and there, became a symbol of the human condition, our duality of logic and emotion, body and spirit, certainty and doubt. The quantum view of the universe dissolved the illusion of separation. It taught that every event, every object, every moment is a pattern in a larger whole. In medicine, quantum physics has given rise to imaging technologies that see within the body without cutting it open, MRI machines that detect the spin of atomic nuclei, PET scans that track particles of light through living tissue. In energy, it has inspired solar panels and superconductors that transform light into power and motion without resistance. Each advance is a reminder that the smallest insights into the nature of existence can reshape the largest dimensions of human life. Schrödinger's wave equation may live in textbooks, but its pulse can be felt in every city illuminated by electricity, every communication sent across the globe, every photograph captured by light. And yet, even now, the mystery remains intact. The same theories that enable technology also reveal how incomplete our understanding still is. Quantum mechanics works flawlessly in practice, yet it defies every attempt to explain why it works. The deeper scientists go, the stranger the world becomes. Schrödinger's cat still prowls within the circuits of our machines, reminding us that uncertainty is not a failure of knowledge, but its foundation. The success of technology does not resolve the philosophical questions, it magnifies them. For Schrödinger, this would have been the perfect outcome. He never wanted physics to become detached from meaning. He believed that the purpose of science was not only to control nature, but to awaken us to its wonder. The technologies born from his ideas are achievements, but they are also invitations. to remember that behind every equation lies a question, behind every discovery a mystery. The wave equation that guides electrons through silicon chips is the same one that describes the orbit of stars and the hum of energy in every living cell. It unites the cosmic and the microscopic, the technological and the human, in the glow of a computer screen, in the hum of a satellite, in the pulse of a laser. Schrödinger's dream lives on. His equation is written into the architecture of modern existence, but so too is his humility, the awareness that understanding the world does not mean owning it. The quantum age he helped create stands as both triumph and testament, proof that imagination can transform civilization, and reminder that even our most perfect knowledge opens new frontiers of mystery. The impact of Schrödinger's ideas is not only in what they built, but in what they revealed, that the future of humanity depends as much on wonder as on wisdom, as much on philosophy as on physics. Through him, the universe stopped being a distant object and became a living question, and in answering it, we discovered ourselves anew. The enduring question, what does it mean to truly exist in a quantum world, remains the most haunting legacy of Schrödinger's dream. It is a question that lies beyond the mathematics, beyond the laboratories, beyond even the boundaries of science itself. It is the question that echoes in the quiet moments when we look at the stars, in the heartbeat that reminds us of our own impermanence, and in the whisper of every mystery the universe still hides. For centuries, humanity believed that existence was simple. To exist was to occupy space and time, to have shape, matter, and substance. But the quantum world shattered that simplicity. It revealed that reality is not solid, that matter is not matter in any permanent sense, and that what we call existence may be something far stranger, far deeper, something that depends not only on what is there but on how it is perceived. In the quantum realm, particles are not fixed things but clouds of possibility. They can be here, or there, or everywhere at once until observation pins them down. Existence becomes a state of potential rather than certainty, a shimmering web of probabilities awaiting interaction. When Schrödinger imagined his cat, half alive and half dead, he was not merely crafting a puzzle, he was holding a mirror to this strange truth. The cat was a symbol of the universe itself, poised between being and not being, waiting for awareness to bring it into focus. In that sense, existence is no longer passive, it is participatory. To exist is to interact, to be entangled, to be seen or felt or measured in some way. Nothing stands alone. This idea changes everything. It means that existence is not the cold fact we once thought it was. It is not a rigid structure built from immutable blocks of matter. It is fluid, relational, alive. A particle is not a thing but a connection, a pattern of energy defined by its relationships with everything else. The same is true of us. We are not isolated observers gazing out at a separate universe. We are part of the same fabric, ripples within the same ocean. Our consciousness does not simply witness reality, it helps shape it. The observer is not outside the equation but woven into it. For Schrödinger, this realization had both scientific and spiritual implications. It erased the illusion of separateness. He believed that the boundary between self and world was an invention of perception, not a fundamental truth. The same awareness that looks through your eyes is, in essence, the same awareness that animates all living things. Existence, therefore, is unity appearing as multiplicity. When we say something exists, we are describing a temporary pattern in an infinite field of energy and consciousness. To truly exist, then, is not to be isolated but to be connected, to participate in the universal act of awareness through which reality unfolds. Quantum physics, in its deepest sense, seems to agree. Entanglement shows that particles remain linked no matter how far apart they travel. The universe behaves not as a collection of independent objects but as a single system, a cosmic web of relationships that transcends space and time. This connectedness suggests that everything we do, every observation, every thought, ripples across the whole. Existence is therefore not static but dynamic, a constant exchange of information and energy. Even the smallest act of awareness participates in shaping the totality. To exist in a quantum world is to live inside a question, not an answer. It means accepting that uncertainty is not a flaw but a feature of reality. It means recognizing that truth may not be singular, that many possibilities can coexist before one becomes visible. It means seeing the universe not as a stage with fixed actors, but as an ever-changing dance between potential and manifestation. Every observation, every interaction, every conscious moment is a movement in that dance, a flicker of possibility collapsing into form. The implications reach far beyond science. They touch how we see life, death, and meaning itself. If reality is participatory, then consciousness is not an accidental byproduct of matter, it is a fundamental aspect of existence. Awareness and being are two faces of the same coin. In that light, death loses its finality. The forms may change, but the field of consciousness remains. Existence, in the quantum sense, is eternal transformation, energy becoming matter, matter becoming awareness, awareness becoming experience. In this view, to exist is not just to occupy a moment, but to be part of an unfolding story that includes everything: the atom, the star, the tree, the thought. All are expressions of one continuous reality discovering itself. Schrödinger saw this unity as the key to understanding both science and the soul. The universe, he said, is not made of things but of experiences, not of parts but of wholes that cannot be divided without losing meaning. To truly exist, then, is to be aware of one's participation in this wholeness, to realize that the boundary between I and the world is an illusion drawn by limited perception. Even as technology advances and our understanding of quantum mechanics grows more precise, this question remains unsolved because it cannot be solved by equations alone. Existence cannot be fully defined. It must be experienced. The universe does not simply exist as an object. It exists as a relationship, an event that happens every moment when awareness meets reality. The particles that compose our bodies, the light that touches our skin, the thoughts that move through our minds, they are all quantum events, constantly appearing and disappearing, constantly renewing the act of being. Perhaps this is what Schrödinger meant when he said that consciousness is the universe trying to understand itself. In the quantum world, to exist is to participate in that understanding. We are both the observers and the observed, the creators and the creation, the dreamers and the dream. Our existence is not an accident within the cosmos. It is the cosmos expressing itself through us. Every breath, every act of perception, every choice we make is the universe becoming aware of its own potential. And so, the question of what it means to truly exist in a quantum world may never be answered in words or theories. It is a living mystery that unfolds within every conscious being. To exist is to be part of the experiment, to be the wave and the particle, the seen and the unseen. It is to recognize that we are not separate from reality, but its very expression. The deeper science looks into the quantum realm, the clearer this becomes. Existence is not a noun but a verb, not a state but a process, not something we have but something we are. To truly exist, in the quantum sense, is to awaken to the realization that the universe is not out there, but within, and that we and it are the same infinite consciousness, forever observing itself through the wonder of being.